Welcome back, everyone. Okay, let's jump right in. Today we're tackling a massive historical cold case. Literally massive. We're talking about the sudden, worldwide disappearance of Earth's absolute largest creatures. We're going to examine the evidence and ask a pretty heavy question. Did prehistoric humans actually trigger the very first global ecological crisis? So grab your notebooks because this is your masterclass in prehistoric forensics.
Here's our syllabus for this explainer. We'll start with the lost giants, then evaluate our two main suspects, climate change and human expansion. After that, we'll look at the synergistic trap they created, the resulting ecological domino effect, and finally, what all this means for us today in the Anthropocene.
All right, part 1, the lost giants. So to understand the crime scene, we've got to look at the victims. Between 52,000 and 9,000 BCE, over 178 species of megafauna just vanished. And when we say megafauna, we're talking about animals weighing over 44 kilos, so anything from the size of a modern sheep all the way up to colossal woolly mammoths and saber-toothed cats. I mean, some giant ground sloths were as heavy as modern African elephants, but they moved incredibly slowly. These were huge, slow-breeding animals, and their disappearance left our planet completely transformed.
Now just look at the sheer scale of the devastation here. Notice how Africa lost only about 21% of its megafauna, but look at the continents that were newly encountered by humans. The losses are absolutely apocalyptic. Australia lost a staggering 88% of its large mammal genera. And just as a quick refresher, a genus is a broad family of species. South America lost 83% and North America lost 72%. It's just mind-blowing.
That geographic pattern is hard to ignore, right? The extinctions spiked the further humans migrated out of Africa. Which brings us to the core question of today's lesson. Where did the giants go? What exactly wiped out so much life in such a tiny sliver of geological time? Did our ancient ancestors actually cause a global crisis?
Let's move on to part 2 and look at the prime suspects, climate versus humans.
For decades, the scientific community has basically been split into two camps. Suspect number 1 is climate change. The idea here is that dramatic environmental shifts, severe temperature swings, melting ice caps, habitats getting fragmented, were what ultimately doomed these creatures. But then, suspect number 2 is the human overkill hypothesis. This theory argues that rapidly expanding populations of tool-wielding humans simply hunted these naive, slow-breeding giants way faster than they could reproduce.
Well, let's examine Exhibit A. This prominent research by Koch and Barnowski points out something really interesting. They argued that the extreme global magnitude of this extinction is actually super difficult to explain if you're only looking at environmental models. Because these slow-breeding animals were wiped out regardless of their specific size or habitat, it really forces us to look much closer at the human element.
And Professor Jens Christian Svenning really hits the nail on the head here. He points out that the extinction hit just as hard in climatically stable areas as it did in unstable ones. Think about that for a second. If severe climate swings were the only culprit, we definitely wouldn't see total destruction in regions where the climate basically stayed the same.
Now, one of the classic arguments against the human overkill theory was always, wait, wouldn't early humans just starve if they hunted their main food source to extinction? It makes sense, right? But foraging models show us something different. Early humans didn't only eat mammoths. We were and are omnivores. Since humans could happily survive on smaller game, plants, and tubers, they could just opportunistically hunt the larger megafauna whenever they happened to cross paths. This meant they could literally hunt a rare species to total extinction without ever starving themselves.
This brings us to Section 3, a synergistic trap.
As it turns out, history is rarely just black and white. The latest meta-analyses suggest it wasn't strictly humans and it wasn't strictly the climate. It was the combination of both. Climate change and human expansion acted together, synergistically, creating this inescapable trap for the megafauna.
Let's look at some hard data from Australia to see exactly how this played out. We have sediment cores showing fungal spores and charcoal, and they perfectly align. They show that frequent human-set fires happened at the exact same time as a massive megafauna decline, roughly 43,300 years ago. Early humans were burning the landscape, and because the climate was also shifting, the pre-existing woodlands simply couldn't recover. So humans essentially destroy the exact habitats these giants relied on to survive.
In class, we see that exact same deadly synergy halfway across the world in Southern California at the La Brea tar pits. The fossil record there reveals that the megafauna vanished in a 300-year window. Just 300 years. And they were replaced almost entirely by coyotes. Why did this happen? Well, charcoal records from nearby Lake Elsinore show unprecedented wildfires popping off right in the middle of a centuries-long mega-drought, which, surprise, surprise, perfectly coincided with human arrival. Humans used fire to clear the brush, and when you combine that with a massive natural drought, it completely, permanently transformed the ecosystem.
Okay, Section 4, the ecological domino effect.
Once these massive ecosystem engineers were gone, we saw a terrifying domino effect. Step 1, the megafauna go extinct. Step 2, without those giant herbivores eating the vegetation and trampling the ground, massive amounts of dry brush build up. It's basically pure fuel. Step 3, that ungrazed fuel sparks unprecedented, super intense wildfires. And this wasn't just a seasonal burn, you guys. These fires permanently changed the landscape, literally turning lush post-glacial woodlands into the shrubby chaparral we see today.
And the thing is, the smaller animals left behind couldn't just pick up the slack. This quote really summarizes it well. The unique ecological roles these giants played, we're talking large-scale seed dispersal, nutrient cycling, keeping the dense forests open. Those jobs were just lost forever. Surviving smaller-bodied animals simply do not replicate the impact of a 5-ton herbivore.
And the tragedy definitely doesn't stop at just fires and plants. Losing the megafauna essentially caused a massive food web collapse. You see, large mammals naturally form way more ecological links per species than smaller ones do. When they vanished, countless vital interactions between species were just completely severed. As a result, the surviving food webs we have today are actually incredibly fragile. They're depop rate, compared to the robust, dynamic ecosystems from 50,000 years ago.
Which brings us to our final section, lessons for the Anthropocene.
Why does all of this prehistoric history matter to us right now? Well, because we're kind of mirroring this ancient tragedy. Just look at this comparison. In the Pleistocene crisis, you had megafauna loss plus climate change, which equaled devastating fires and habitat loss. Sound familiar? Today, our modern crisis combines extreme biodiversity loss, rapid climate change, and invasive species. And it's creating the exact same explosive fuel structures and severe modern wildfires across the globe. The dynamics are strikingly similar. I'm going to leave you with one final thought, a little piece of homework to ponder. We now know that human actions, combined with the shifting climate, triggered the very first global ecological crisis. We absolutely possess the power to irreversibly alter the Earth. So, as we navigate the Anthropocene today, will we learn from this and use our knowledge to save the remaining giants of our world, the elephants, the rhinos, the whales? Or are we just doomed to repeat the mistakes of the past? Thanks for joining me for this explainer class. Think critically about this one, and I'll see you next time.